Now, this is going to be our second lesson, lesson 2 on circle properties. And now we are going to dig deep into the theorems. So that is what we are going to do. And I'll expect you by the end of this lesson, at least to know the first theorem of what we call of circles. And we shall be relating angles made by an arc and then the circumference and the center. Now, what is circle theorems? Now, when they talk about circle theorems, they are referring to those properties that show relationship between angles within the geometry of a circle. Whenever you are dealing with a circle or whenever you have a circle, in real life, you'll find that in this circle, there are angles that you are going to form. Take an example. When I join a line, this is a chord, and I join it to another chord like that, you are going to notice that there is something I have formed that may be at this point of meeting, where when one chord meets with another chord, I'm forming an angle. When you check out, I can have another thing that this is my center. When I join the radius and another radius, you are noticing that inside here, I'm forming an angle. But also you can notice that when I have this as my circle, I have this as my diameter. But also when I come here and maybe I draw another, let me say, I just draw another line up to here, or I draw another line here as a chord, you are noticing that there is something I'm forming, that I'm forming some angles. So under circle theorems, we want to check out, we want to verify, we want to look at that kind of relationship that is going to be existing between the angles we are going to be forming within these circles. So we are going to look at the angles, we are going to look at the triangles we form, and which kind of relation are those different things, the sectors, the segments, the radius, and the diameter form when we are looking. So that's briefly about what we call circle theorems. So circle theorems, we are looking at the properties that show up, all those properties that exist between the different angles that we form within a circle. So for you, when anything you draw within a circle, it has a property that governs it. So for even if you just come and you draw something like this, as long as you are going to form an angle, it means that there is a property that we are going to be utilizing to find out which angle is there. And that angle that is there, here at this point, we are not going to be using a protractor to measure those angles, but we are going to be using theorems that have been verified already to find out which angle is existing. So that's what we are going to be looking at. That under theorems, here we are not going to use the protractors to measure that you are going to do the circle, but you are going to be just applying the theorems to find out that that angle is this, without majorly going into use of the protractor to measure, going into drawing using a compass and the rest of that. So those are what we call the circle theorem. Yes, and we are going to use it with the help or with what we call the prior knowledge that you have been able to gain. Yes, and here are some of the knowledge that you need. You're going to need your knowledge from triangles. You looked at triangles in senior one, or what you call angle properties. So you looked at those ones. We shall be applying that knowledge when it comes to our calculations. Okay. So you can make a simple write-up about circle theorems. When you finish, you let me know. Okay, since people have finished. Okay, okay, okay. I've finished. Okay. Uh, we are going to continue. Now, we have what we call the main circle theorems, and these ones are 7. However, at this level, we shall look at mainly 6 of them. So the first one, the first theorem is going to be angle at the center, circle theorem. We shall look at which property govern when we have semicircles. What about when we have quadrilaterals? What about when we have segments? So each of those ones has a theorem that is going to be that we are going to be employing. So those are the 7 ones, the 7 major ones. However, we shall look at basically 6 of them, but also I'll maybe talk about the last ones, the tangents and then the chord. So you can write. Now, by the end of this topic of circle theorems, you must be able to know all those theorems. You need to know how they work such that you can be able to find those different angles whenever it comes to the different numbers that they will be giving you. So you can summarize them, and then maybe after the topic, you'll be evaluating yourself that maybe I know this theorem, I can do the numbers on this, I can do numbers on this. You'll let me know when you finish. Yeah, looking through the chat, it seems people have finished. Can give just 1 more minute. Yeah, but here I'm not seeing Paul has finished. Favor, Paul, Magezi. Okay. I think we can continue. Now, I gave you this activity yesterday for you to try out. Unfortunately, we are not going to do it here because I gave it to you yesterday, and I expect you to have tried it out. So allow me to just ignore it, and then I go what I was interested in. Now, those people who tried out this activity, I picked, some of you sent me your photos, but I just picked out a few of the photos that I received from the activity. So one of the person sent me this photo here from what the person had obtained. So one person obtained this, and another person also did something like this. But from what they did, because I told you that you must get a circle or something circular. And when I look at this, I don't know that it was a cake board or what. It looked like a cake board, but I know maybe someone just cut something. So you can notice that she was able to get a circle, and then it was up to her to come up with to draw a line. So she went on, you label that this is 1 point and this is 1 point. So when you label like that, let me say I've drawn like here and I've drawn here. So from her diagram, you can notice that the angle she had here, she had a 60. And the task was that from these points, you draw any line to the other outside part. Remember, this is what now we call the minor sector. So the lines that you were supposed to draw were supposed to meet in the major sector. So you cannot that, oh, they were supposed to touch the major arc. So anything you draw here, let me say you draw here, or whether your lines come like this, as long as they're in that side of the major arc, all these angles you were supposed to get had to have some relation with what you have in the middle. So this is what people came up with. And you can note that this person here got a 60 here. And here when the person measured, she found out that this was 30. This person here, still here, for this person had a 60. When he tried to measure, here he had a 30. So you can note that there is some kind of relation between 60 and 30. And that kind of relation is what we are going to be looking at in this particular lesson. That which kind of relation exists, and that one is going to give us our first theorem that we are going to be dealing with in this lesson. But from whatever they did and all those people who tried out, what you notice is that the angle that is always at the center is always twice the angle you form at the circumference. When you look at this person, you can tell that this angle is 60 and this angle here is 30. So the theorem will tell us that the angle that you form at the circumference, this is the circumference here, is always half the angle you have at the center. That the angle at the center is bigger than the angle you have at the circumference, and it is always twice. So let me see whether people can tell me, if this angle here was 80, which angle shall we expect here? Use the chart. If this angle here was 80, which angle shall we have expected to get here? Daniel is saying 40, 40. Very good. Yes, yes, perfect. Now let me give you another. If the angle we had here, here, you are not saying, if the angle we had here was an angle of 25, which angle would you have expected to have here? Very good, very good. Now, that is now the kind of relation that we are going to deal with. So always, you must look at it in that particular direction. So for you, what do you need to always to take out? Always, you need to find out that kind of relation. But as we dig deep into what you call the circle theorems, there are some keywords that we are going to use. And one of the keywords that is going to be appearing is what you call subtended. This word, in all theorems, you are going to find the word subtended. Now, subtended originates from Latin. This one is sub, and this one in Latin comes from what we call tendere. And tendere, just this one, it means to stretch, to extend. Yeah, this is what it means in Latin, tendere, which means to extend, to stretch, and the word sub means under. Now, when we talk about subtended angle, when you have a subtended, now since here we are talking about circles, but I'm going to use two things. Whenever I have a line, let me say this is my line AB. And I have another line. This is my line, B and C. You are not seeing that when this line meet, they are forming an angle here. Let me say this is angle theta. Now, when we talk about this angle we are forming here is what we call a subtended angle. So subtended angle means that angle that is formed by two lines. Whenever two lines meet, they form an angle. So that angle they form, we shall be calling it a subtended angle. Now, here when we are talking about a line, you are not saying that A and C, they are also going to form for us a line. So when you look at this angle is opposite line A to C. It is facing line A to C. So when I'm talking mathematically, I will say that I can say that the side SC subtends an angle theta from point B. So mathematically, I will say that the side AC subtends angle, the angle theta from point B. This is how I will say it mathematically. So when now this side SC is the one that makes or forms for us this angle. So where it faces, so let me hope you have understood that side SC subtends the angle theta from point B. Now this is just about a line. But since I'm talking about a circle, now a circle, I'm going to draw my circle like this. When I draw my circle, any angle that we are going to form as a result of two chords meeting, that angle shall be calling it a subtended angle. Let me take an example. I have my chord. This is my chord here. This is one chord. Because we say that a chord, this is, let me say A, and this is B. We say that a chord is any line that joins any 2 points on the circumference. And now take an example. I have another chord. Let me say this is my chord, and let me call this line B to C. Now, when you look at these two, you are noticing that they are going to be forming an angle at this particular point. And when you look at the point where they are forming, this is point B. And point B is on a circumference. We say the circumference, that's this red thing is what we call the circumference. That circular thing that forms a circle. Yes. Now, when you notice they are forming an angle at the circumference. Now, this angle here that has been formed is what we call the subtended angle. But this angle that has been subtended, it is being subtended by this one here, A to C, and A to C is what we call the arc. So this angle here, you are noticing that it is being formed by A to C or by arc SC. So this angle here is what we call the subtended angle. So here we shall say that the arc SC subtends an angle theta from point B. So for this particular, we shall say that the arc SC subtends the angle theta from point B. Kindly let me know in the chat whether we are okay with that particular thing. Whenever you hear the word subtends, it means that two chords are meeting and there is an angle that is being formed. But now your task is always to find out what forms that particular angle. Kindly let me know through the chat. Are we okay with that? Okay. Okay. Perfect. Perfect. Let me now ask you to just write about subtended angle. Yeah, because the moment you hear that word, it shouldn't confuse you. So you write about it. So when you finish, you let me know. Okay, done. Done. Okay, I think people have finished. Okay. Okay. Now we dig into now the theorem. Okay. Now, this is how our theorem is going to look like. Now, angle at the center of a circle. Now, whenever you have the angle at the center of a circle, this is our theorem, and the theorem will say that the angle subtended at the center of a circle by an arc is twice the angle subtended at the circumference by the same arc. When you look at, now this angle here, you are noticing this angle here is what we call the subtended angle. That one is what we call the subtended angle. It will depend on which book you are using. In some books, you'll find them being called an inscribed angle. Then the angle we have here at the center, this one here, is what we call the central angle. So central angle comes from center. So it is the angle at the center. So the theorem will tell us that the angle we have at this center, like you have noticed that this is my circle and this is my center. So when I form any angle at the center, to form any angle at the center, it means that I must join two. I can join two. This is a radius and this is a radius. So this radius is going to form for us an angle at this point. And when they form for us an angle, remember, if this is my A and B, this part here is what we call the minor sector. Now, any line that is going to only, so this side here, this is where you have the major arc. This is the major arc, and this down here is the minor arc. Now, for any angle we are going to form on the major arc, as long as it is going to come from A and B, that angle will always be half the angle we have at the center. Take an example. When I draw a line from A, I draw another line from B like that. The angle I'm going to form here is always going to be smaller or half the angle I have at the center. Even when I come and I do like this, I draw from B like this, I come, I draw here. The angle I form here is also going to be half the angle I have at the center. Even when I come and I draw something like this, I'll draw like this, I come, I draw like this. As long as those angles are on the major arc and they are coming from the same arc, A, B, those angles are always going to be half the angle you have at the center. And that is the first theorem that we need to know. Hope that is very fine. So that theorem is going to form our first theorem, and it's where I want to emphasize. Now, how do you label these theorems? Take an example, the first one. When you note this is A or B. So when you are writing, I write A or B. Now, this one here in the middle letter is what tells us where our angle is. So I write A, O, and then B. So this is. Now, angle A or B will always be, is equal to twice the angle we form at the circumference. So here I'm going to come and I will say, allow me to remove this. Now, at the circumference, what do we have? Oh, sorry. At the circumference, I'm going to come here and I say, I have A to C, then to B. So I will say is twice angle A, C, B. And this is the theorem. Members, let me know whether you have understood that one. That angle A or B is equal to twice angle A, C, B. Is that one fine? Let me know through the chat. Has everyone understood that? Yes, yeah. Okay. Understood. Okay. Now, the same theorem, I want us now to focus. This is, let me say part one. Now, I want us to look at part two. Now, when I'm looking at part 2, allow me to draw my circle here. Now, when you look at my circle here, this is my center. Now, I have drawn here, this is my radius, and this is my radius. When you look at it, you are noticing that I'm forming an angle. And which angle am I forming? I'm forming this angle here. Now, this angle I'm forming is what we call a reflex angle. Reflex means an angle beyond 180, that angle. So this is a reflex angle. It means that if this is A and this is B, the arc that is forming this angle is this bigger arc here, is the one that is forming that angle, that I have considered the major arc to form the angle. So it means that any angle, so this is our bigger angle. It means that any angle that is going to be formed on the opposite side, this is the major arc. Now, any angle that is going to be formed on the minor arc is always going to be half the angle at the center. So if I come here and I join from here, this is A. I join to B and I draw a line from B. The angle I'm going to form here is always going to be half the angle I have. Even if I come and I draw like this, I draw like this. As long as that angle is formed in the minor area, that angle is always half. But I don't want you to confuse it that here, this is the major angle. And this angle is reflex. It is beyond 180. And it is being formed by the major arc. So for this case, this is what we call the subtended angle, or this is what we call the central angle. So the angle that is being subtended by the major arc is this angle here at the circumference. Hope we have got that one clearly. Take an example. I want people to tell me if this angle here is 260. Tell me in the chat, which angle shall we have here? I'm just checking. If that angle is 260, which angle shall we have at the circumference? Good. Virginia, Jum, yes. Okay, yeah. Now that is the theorem. So the diagram can come basing on that. So for you, what you need to do, always you check out and ask yourself which theorem has been applied. So for this one, theoretically, I'll write it. For this pattern, I'll write that if this is my A, and this is my O, the center, and this is my B, and this is my C. Can you write for me in the chat a relation of this nature for this particular one, for Roman 2? Can you write for me the chart, the relation? How shall we write this relation for this part B? Let me divide. For this part B, how shall we write this relation? Write it in the chat. Some people are lost. Okay, Michelle and Didas. Okay, Didas, I'm going to repeat a bit about it. I want to see how people can write for us that relation. I want you to write a relation which of this nature to show me how those two things are connected. Let's try and see. If you wish, you can even raise up your hand and you tell us what you think. Okay. Okay. Yes, Patricia.
Okay. I think when I get the text, arc A or A or B subtends the angle. What's this? Theta. Okay, let me just call it theta. At point C.
At points. Okay. Yeah, that is okay. This X, Yes. What I like, okay, thank you, Patricia. Now, here in summary, we shall say that angle A or B. So here O is this angle here. So don't think that I'm using this angle. O is this angle here. This one here is what we are calling our, is always angle A, C, B. So that's how you write your relation. So can we summarize those two things in the chat in our books? Summarize those two theorems. And that is the theorem we are going to be dealing with for this particular lesson. Once you understand that theorem, we shall be good to go. So the first steps always you have to do is locate the major things. For these theorems, I want you always to observe. First check, where is the center? Where is the central angle? And where is the inscribed angle? So you check out the center, check out, do you have a central angle? What forms the central angle? After finding that one, then you go on to apply the theorem. Identify that this is the minor arc. So anything, in case the angle has been formed by the minor arc, anything in the major arc will be half the angle at the center. If it is the major arc that is forming, anything in the minor arc will be what? Half of what you have. So people who are lost, I'm just repeating for you as people are summarizing. Yes, I want to repeat mainly, I think this part too. I'm saying that this is our circle. Always first find out the center, that this is my center. After finding out the center, ask yourself what forms that particular angle you are going to deal with. That maybe my angle is here and here. That this is the angle that is being formed. Take an example, this angle is maybe 260. Then ask yourself, if this angle is formed by the major arc, this is the major arc. It means that any angle that is going to be formed in the minor area. Now, the minor area for this particular one is going to be this one down here, this one here. It means that any angle that is going to be formed in that area is always going to be half the angle in the major area. So now I will come, and always please take note that always the angle formed must originate from the 2 points of the radius. So if I come, I form like this and like this. So you are noticing that one line is coming from B, another one is coming from A. So this angle is going to be half what you have in the major thing. So if this is 260, this one is going to be half of it. So it is going to be 260 divided by 2. Let me hope now we are on the same page, everyone. Yes, Joel, that is true. Are we on the same page, everyone? Okay, Christian says yes, yes, okay. Have we finished right? Now I want to just know, I want to get to find out whether we are finished right, and then we dig into the examples. Has everyone finished right? Such that we can start on the examples. Okay, Anointed Daniel is saying yes. Michelle is saying yes. Paul, yes. Okay. Okay. I think uh, we can start. Okay. Okay. Now we are going to start on some examples. such that we can understand. That is my first one. And I want everyone to first try out and you tell us your answer in the chat. Okay, Daniela is getting that answer. Favor is getting that answer. Okay, everyone, we are trying. Okay, I think people are still calculating. Okay, Victoria. Okay, Emma. Okay, very good. I've seen the answer. Now, when we are attempting the first, I'm going to be encouraging you, always you can first label that this is my A, this is B, and this is C. Now, like I've told you, first find out what do you have. You are noticing that your central angle is formed by two radii. It is formed by A to O and O to B. So you are noticing that this is your circle and I have this angle that is being formed at this point, and this angle is 106. Like we have said that now this is the angle. Now the next thing you're going to ask yourself, what is forming my subtended angle? That the subtended angle is formed by which arc? Arc A and B. This is our arc. Now, any lines that are going to be originating from A to B, going into the major sector, this side here, or where the major arc is, that angle is going to be half of what you have here. So whether the thing has come like this and here, whether it has come like this and here, whether it has come like this and this, always that angle formed here is always going to be half. Hope that one is very, very okay. Now, from our diagram here, I don't want you to always just put your answer. You must put it in a way. Let me say this is A, B, and then this is your C. So I want you always that when you are answering, you write it. So you say that my angle A O B is equal to twice the angle I have ACB. Then from here, and then here, sometimes it is a good practice even to put the theorem. Yeah, those who can, yes, you can put you can even put the reason, because now here people may not know why you are saying so. So you can put here, say, and now here the reason is the theorem. Which theorem are you applying? And here you can say angle. Here, this is angle subtended at the center is always twice the angle at the circumference. So that is the reason. Then after here, you come and say my angle AOB is 106, which would equal to twice my angle ACB. So to get ACB, I'll divide by 2, divide by 2. And from the chart, I'm noticing people are getting 53 degrees equals to angle ACB. So you must show how you are getting it. Much as now I know it is clear to you that you just need to, yeah, but you need to show how you are getting it. Members, are we good to continue? Should we continue? Okay. Victor, okay. People are saying yes. Okay. Yes. And for now, since we are, yeah, okay. Okay. People are saying okay. Yeah, please feel free to use a free hand when you are drawing the circles, such that we do not take a lot of time. Okay. Now let me ask here, can someone raise his hand and they take us through this one? Anyone can raise up your hand and then you take us to this number. Okay. Yes, Virginia. Unmute.
Morning, sir.
Morning.
Teacher, you could help me name the left side A and the right side B and the bottom C.
Okay.
So we're going to first state that A or B is equal to 2 ACB. Then we proceed to work out 220 degrees is equal to 2 ACB. We divide both sides by 2. And then we get 110.
Okay. Thank you, Magezi. Let's hope everyone is getting that. Okay, that is correct. Thank you, Virginia. If you are getting that, just know you're on track. Okay, you let me know whether we can continue. So for this particular one, you can now note that here we have our angle that has been formed in the has been formed by, this is the arc that has formed it, this one here, the major arc. So anything formed in the minor, as long as it originates from the major arc A, B, will always be half the other side. So you can notice that even sometimes they can trick you. They can draw it like this, something like this. For you need to just know the theorem that as long as the line where the minor arc is, or now the minor sector is, as long as the line is coming from A and from B and they are meeting at the circumference, this angle here is still going to be 110. Even if it is something like this and from here, still this angle will be 110 degrees. So please take note. Even if now, even for that particular, even if they had drawn it in this format that this is 220, and you look at it and you see something very small, you see something like this, and they tell you the angle here. Still, since it's coming from the major arc A and B, any point they meet, this angle will still be 110 degrees. Okay, I think we can continue. Can we continue, members? Can let me know through the chat. Okay, we're saying we can continue. Okay, I have another one. Can everyone first try out? Can everyone first try out? always it is a good practice. First label. Yes, first label your circle very well. You can say this is my A, this is my B, and C. Okay. Yes, Juma? Juma? Yes?
Yes, good morning, sir.
Yes, good
Good.
morning.
Yeah.
Yes, Juma, you
So
can go
for me,
on.
when I was doing, I got
Hmm.
angle,
You good?
angle A or B.
Hmm.
No, let me
You say you good? Angle
angle A or C,
A or
A
C?
or
Hmm.
C,
Hmm.
mm, A or C, okay,
Hmm. Is equal to
twice angle ABC,
angle A, B, C. Okay.
meaning X is equal to 2 times 102.
X is equal to 2 times 102.
Yes, where I get X as 204.
And you got your answer as 204 degrees. Okay, that is very correct. Thank you. Yes, yeah.
Yes,
Hope everyone is getting that. Okay, looking through the chat, I think Christian, could it have been just an error? Yeah, it is 204 degrees. Okay, same. Okay, yeah. Okay. We are going now to continue to another one. Now I have another one here. Now, like I told you earlier on, that when we reach at some point, we shall be bringing in the angle properties. And when I'm digging here, I want us to be very observant. When you look at our circle, I'm going to break that circle. This is my circle, and this is where my center is. The distance from here, from the circle to the circumference, we call it the radius. The distance from the center to the circumference, we call it the radius. Now, I want you to know it that these two, since this is a radius and this is a radius, these two are equal. So that distance must always be equal. Similarly, when I look at this circle, this one is a radius and this one is a radius, meaning that this and this are equal. Are we together? Now, when you look at that circle, you are noticing that we are going to be forming a triangle of this nature, whereby this is a radius and this is a radius, and we have here 12 degrees. Can I know through the chart, what is the special name for this triangle here in math? How do we call that triangle? Don't mind about the spelling. I want to just to find out whether people know the name we give to that triangle. What special name do we give to that particular triangle that has two sides? Thank you, Jim. Patricia, yes, true. We call it an isosceles triangle. Yes, Victoria, Daniela, Joel, yes. We call it an isosceles triangle. And when it comes to an isosceles triangle, there is something special about it. When you look at this triangle, this is the base, the base of the triangle. What do you know about this angle that I'm calling C? Or what is the size of that angle C? What is the size of the angle C? The angle C is 12. Emma, Virginia, Favor, Diego, Joy, yes. Samsung, Christian, yeah. That angle is 12. For any isosceles triangle, the base angles are equal. Now, when I come back to my circle, this is 12. It means that the angle I'm going to have here is also going to be 12 degrees because this is an isosceles triangle. So our isosceles triangle is being formed by this line here, and then this line here. You are noticing that that is a triangle we have formed in our circle. Now, in order for us to find out B, it means that I need to know the center angle, the angle here. Allow me to call this angle here for our particular angle. Let me call it X. So mean that in our triangle here, we have X. Members, can we find out what X is? Can we find out X is? Or someone can raise up the hand and you take us through what you think, how we can get that X. Diego has got the answer. Emma has got the answer. Good. Shakul. Okay. Redmi. Okay. Pearl. Okay, I'm seeing people are getting the answers. Very good. Yes. Now, those who don't know, we are getting the answer. Angles in a triangle add up to 180. It means that when I have my angle X plus 12, this 12 here, plus this 12 here, I must be able to get 180 degrees. So here we collect like terms, we shall say X plus 12 plus 12. So you add up that to the 12 plus 12, and we shall get 24 will equal to 180. Then after you collect like terms, you say X plus 24 minus 24 will equal to 180 minus 24. And therefore our X will equal to 180 minus 24, which will give us 156 degrees. So now, after obtaining 150 degrees, then you can go back and calculate what your angle B is, because now the property they have used is still the same property. This angle at the center we have formed is 156. And we say that if this is my A and this is my B, any angle that is being formed in the other area of the major arc, as long as the lines are originating from this small arc or minor arc AB, the angles are always going to be half. So the angle you're looking at we are forming is an angle originating. So can everyone be able to calculate it? So calculate and tell us what is your B. Someone is saying 78. Paul said 76. Patricia is saying 78. Jory is saying 74. I'm saying our answers are a bit varying. Can we have someone raise up the hand and then you take us through what you are getting? Okay. Yes, Patricia.
All right. First help me name sides. At the left A, B, and then C.
Yeah, we on the center.
Point O.
Okay.
So angle AOB is equal to twice. Angle ACB. Then our angle AOB is 156. Is equal to twice angle ACB. And we divide both sides by 2. 156 divided by 2, that's 78. It's equal to angle ACB. So
And our angle?
Angle B is equal to 78 degrees.
Very good. Therefore, our angle B is 78 degrees. Okay, thank you so much, Patricia. So that's how we obtain that angle. Let me hope, are we on the same page, members? You can let me know through the chat whether we are okay. Are we good to continue? Okay. Okay. That's saying yes. Okay, we are going to continue. Okay. You are going to try for me this number. Let us first try out, and then after, put your answer in the chat. Joel is saying 37, Mark is 37, Victoria 37. Okay, who's taking us through this number? Anyone who wants to take us through the number? Okay, okay. Okay, I don't know what's the first favor.
Good morning.
Yes, good morning.
So we see that this angle here where we have 53 is formed by this line that connects to the center. And so we should mark it and make it equal to the other opposite to it this side to show that it is an isosceles triangle. Yes, like that. So that shows us that this angle, this side is also 53 degrees.
Mm.
And so we label the one up maybe X.
This one?
Yes.
Okay.
So we are going to first find X. So we all know that the total sum of an interior of the triangle is 180. So X plus 53 plus 53 gives us 180. So X plus 106 is equal to 180. X plus 106 minus 106 is equal to 180 minus 106. And then our X will be 74 degrees. So then we shall say that, we label here A, B, and then see the other side. Yes. So then here, obviously our sector is O. So angle AOB is equal to 2 angle ASCB. Yes. So our AOB is 74. Yes, 2ACB is equal to 2ACB. Yes, so we divide by 2. Then it gives us the 37. So angle C is 37 degrees.
Thank you so much, Favor. Okay, hope everyone has been able to obtain that. So the questions can be twisted. Joel, hope you had the same. Yes, Joel, you'll do for us the next one. So that's how we expect you to approach such a number. So it can be twisted in any format. So, but for you always first identify what forms the central angle, and then now after look out for the subtended angle. Sometimes even they may give you, like they can give you C and they want you to find the angle here. So you must be able to do that. Maybe allow me to give you one. Okay. I think hope people are finished to write. Yes, what I was saying, sometimes they can give you can find a circle of this nature, and maybe they give you here, they stretch it up to here, they bring it like that, then they'll put for you, then they can come, do something. They can use the same line here. I bring it like this. And then I bring it like this, something like that. Now, for you may be confused, failing to note that still from here, the line is touching the circumference. Then I'll come and I say, this angle here is 48 degrees. Then I may ask you, find for me this angle here. Let me name this angle to be B. Can we try out that? This is my center. I've given you here 48. Now I want you to find angle B. Can we find out what our angle B is? Uh, I guess it's getting 42. Okay. Okay, 42. I'm saying people are getting 42. Okay. Those who are getting 42, you are correct. Yeah, it is 40, 42. Perfect, perfect. So in case those are the angles you are getting, 42, yes. So here, I shall expect someone to come find out this angle. Then you notice that this and this are radius. Then you know this angle is also angle B. Then you add up all the angles equal to 108. Okay, Priska, I'm saying, yeah, we are there. That is very good. That is okay. So allow me now. Yeah, I think you can take a screenshot. This is just a simple exercise you're going to try out in your free time. Oh, but why don't we first do number 2? First do for me number 2. Do for me number 2. Yes. 80, 80. Joel is getting 40, 80, 80. Okay. Joel, can you take us through? I'm saying it is only your answer that is a bit different, so we need to know. Joel, are you ready to take us through? Or Joyce? I think. Okay, yes, Joel.
What I first did was to find, let's mark that angle next to 140 degrees, X. Oh, not
This one here.
Y. Yes.
Okay.
So I first found that angle using 140 degrees, 180 degrees minus 140 degrees,
Yeah.
where I got 40 degrees. And then I found X using A or B is equals to 2 SCB. Help me label the
Okay.
so I used A or B is equals to 2 SCB. A or B is X, which is equals to 40. Oh, wow, I see why I made a mistake.
Okay.
So X is equals to 80.
X is equal to 80. Okay.
Yes.
Okay. Okay. Yes. So you are not saying that here Joel was able to use angles on a straight line. So sometimes you may find that you're going to use angles at a point. Take an example. For this particular one, they can hide this 110 and instead they give you the angle here. Let me say they can hide it and they give you an angle here as 250. So in order for you to use the property, it means you must first come and find out the angle you have here, knowing that angles at a point add up to 360 degrees. So you need to be very observant and then you think, yeah, okay, you are going to, these are just your numbers for trying out. You can take a screenshot. Okay, hoping you have taken a screenshot. You can take a screenshot of that as well. Okay, so allow me that we are going to end here our lesson. We shall always be ending early before 7 a.m. or at exactly 7 and not beyond that. So allow me to wish you a good day. In case someone has a question, you can ask now. Yeah, in case there is any question. Okay, since there is any question, allow me that we end here. Let's meet tomorrow. Okay, I'm saying, okay, Virginia.
Teacher, where we will be able to find the recording for the first part?
On the YouTube, I'm going to post them after, I think after some 30 minutes from now. I'm going to be posting them on YouTube. Okay, so in the afternoon, when we meet in the afternoon, we shall be doing a senior 4 work. I know today there is math on the timetable, and today we shall be doing senior 4 work. But I'll be sending this work on your, you're going to be finding this work on the platform. I'll post it there, and then you can be able to access it. Thank you so much for attending. let me wish you a good day and bye-bye, everyone. Let's meet tomorrow.